Let's look at question number 7. Let's just say that SD represents the sum of the digits of n, just to give us a nice notation. And I suppose you guys know that if the sum of the digits of n is a multiple of 9, then this also means that n is a multiple of 9, and vice versa. So let's just call this 221 digit number n. So here we've got that a is the sum of the digits of n, and because it's 221 digits, then the largest that a can be is when all of these digits are 9. So we've got that a is smaller or equal to 9 times by 2021, and this is just equal to 18 something. Okay, with this is just 3 digits. Then we've got that b is the sum of the digits of a. Okay, and the largest this can be is when, well, all 4 of these are 9, and this one is a 0, so that is 4 times 9, or when this is 18 and these are 3 9s, but that still gives 4 times 9, which is 36. And then c is the sum of the digits of b, and the largest b can be is 36, so the largest, the sum of its digits is 9. So what's the largest possible value for b? It's 9. Okay, let's look at question number 8. We've got an octagon. Its sides are all 50. Now, a little bit later on, I'll prove in like a tangent that all of these angles over here must be equal to 135 degrees. Now we are asked, what is the height of the stop sign? So I'm going to just draw the height here through those 2 points, and this is perpendicular to that. Then because this angle is 135 degrees, this angle must be 45 degrees. This just suggests that I should draw in this right angle, and I'm also going to draw in this right angle with this 45 degrees. Then this is a rectangle, so this part will be 50. This is that special angle triangle, so this will just be 50 divided by the square root of 2. This will also be 50 divided by the square root of 2. Adding everything up, we get that this is 50 plus 2 times this, which simplifies down to a. Okay, for this question, let's suppose that there are X boys and they each have X rand, and there are Y girls and they each have Y rand. So the total number of rands that they have is X squared plus Y squared is equal to 697. So basically we have changed this whole sentence into equation, and we also have that X and Y must be elements of the natural numbers. Then the question asks, The question states there are two ways to decompose 697 into the sum of two squares, and the question asks how many kids are there in the two classes combined. So we have to find how to decompose this. Now, from experience, I know that it doesn't take too long to try different values for x squared, and then just calculate 697 minus x squared and check whether this is a perfect square. Also, from experience, I know that I can reduce my workload by saying, okay, one of these two are going to be bigger. Let's just say by symmetry that x squared is the largest one. Then we get that this over here is smaller than 2x squared. Okay, I probably should put a larger or equal to sign, because we don't, there might be a case where they're equal, although we very quickly can see that's not going to be a case. Then we get 2x squared is greater or equal to this, which is that, and I can divide by 2 and I can get that x squared is greater or equal to 697 divided by 2. So that reduces the number of x squared values I have to check. Also have that x squared is smaller or equal to 697. So from this I can run through all the perfect squares that lie between these two numbers. I could also do the same for y squared instead, or alternately do the same for y squared. We have that if x squared is greater than y squared, I can get a bound for y squared by just using this inequality over here. We get that x squared plus y squared equals 697, and this is greater than 2y squared. Dividing by 2, we get y squared is less than or equal to 697 divided by 2, and also clearly y squared must be greater or equal to 0. And this gives a range of values for y squared. Now, both of these ranges are the same width of 697 divided by 2. However, as we get to larger numbers, the perfect squares are more sparsely spaced out. So this range over here is going to contain less perfect squares. So it will be faster to work with this range. Okay, now let's work through the various x squared values, and let's also work out 697 minus x squared. The largest x squared is 26 squared, which is equal to 676. Subtracting this, we get 21. Just a side note that you can go and do. If this over here is a multiple of 4 plus 2, it will never work on this side, and you can work out why. Then we get 25 squared. This is something that ends in a 5. If I take this, subtract it from that, we get something that ends in a 2, which is not allowed. 24 squared, that is 576. If I subtract it, I get 121, which is 11 squared, so 1 possibility. 23 squared, that is something that ends in a 9. 9, yes, that's not allowed. 22 squared, that is something that ends in a 4. Subtracting, we'll get something that ends in a 3. 21 squared, something that ends in a 1. Okay, that's a possibility. 441, we get 6, 3, no, what's wrong with me? 5, 2, 5, 6. That is 16 squared. So we've got both the cases. Question implicitly implies that there are only 2 possibilities. So I don't need to go further, but if I did go further, I'll get down to 19 squared, which is about the halfway point. Okay. So one possibility is the one class has 24 boys and 11 girls. Another possibility, it has 11 boys and 24 girls. Another possibility is it has 21 boys, 16 girls. And another possibility is 16 boys, 21 girls. Now, they state that your class has more kids than mine. In other words, they have a different amount of kids in the class. So we get that only one of these 2 possibilities is possible, and only one of these 2 possibilities is possible. And the sum of this is 35. The sum of this is 37. And if we add these together, we will get 72. Okay, question 10. We just have to express this as an equation. Here we've got the 2 smallest consecutive integers, so it's consecutive integers. So let's say it's x and x plus 1. Then it has the properties, the squares differ by more than 100. So we've got x plus 1 squared minus x squared must be greater than 100. And all we have to do is just solve this, and we get 2x plus 1 is greater than 100, which basically means that x, I just noticed this like shortcut, but let's just go through this. Then this means that x must be greater than 50. So the smallest possible value of x is 50, then x plus 1 is 51, and ask for the sum of the 2 ages, and that will give you 110. Okay, just a slight shortcut. The sum of these 2 ages is 2x plus 1. So all I had to really do was look at what's the smallest odd number greater than 100, which is 101.